Hello students, having understood the block diagram of cathode ray tube, let us go to the next topic, which is again related to cathode ray tube, which is called as electrostatic focusing mechanism. This is very important that you understand. Of course, this part or the things which I am going to explain under this heading will be nothing but the explanation part of electron gun assembly. We just have to understand how the CRT focuses the beam of electrons into a dot, a narrow sharp dot, so that whenever it strikes on the screen, whenever it is bombarded on the screen, it produces illumination, a dot, green color dot, which will be produced on the screen, and that dot has to be moved on y-axis as well as x-axis at the same time to form an image which has to be analyzed. So that is what is the basic purpose that which we have understood in cathode ray tube. So now how focusing is done, again the same thing I have explained you in cathode ray tube, but this type of question can be asked. Explain electrostatic focusing mechanism in CRT. So I am explaining you on that basis, so that you can write the answer for that particular question. So now again the diagram which we will draw will be the same which we have drawn for CRT's. Few things we will keep on assuming. Okay, so now there is a base. To the base there are number of pins which are attached, and when power supply is applied to pin, filament is there, filament gets heated up, filament is used to indirectly heat the cathode element. As soon as cathode element is heated, it emits electrons. This electrons then passes through, this electron is passed through a nickel cylinder with a tiny hole at the center. Okay, the nickel cylinder with a tiny hole at the center, we call this as control grid. So basically what happens is, in the block diagram of CRT, we clearly specified that the control grid is connected to external negative potential, which controls the intensity of the image on the screen. In easy language, it controls the brightness and contrast, right? How it controls? By controlling the amount of electron which is moving out of the control grid. I clearly said that this is connected to, control grid is connected to external negative potential. If the negative potential is increased, less amount of electrons will be moved out of the control grid, less of the electrons will be bombarded on the screen, so intensity will be less. And if the negative potential is less, repulsion will be less, more amount of electrons will move out of control grid, more electrons will be bombarded on the screen, and more will be the intensity. So we are controlling, by controlling the negative potential of the control grid, we are controlling brightness or contrast. But in terms of CRT, we say intensity of the image on the screen. That is what we are going to control by the negative potential. Now for this electrons to produce illumination, it should be bombarded to the screen with a very high velocity, right? For that we need, what we do is we have three anodes, right? Three anodes. When you say anodes, that means they are connected to positive potential. They are connected to positive potential. Now these three anodes, which are pre-accelerating anode, focusing anode and accelerating anode, they do two things. First, they accelerate the electrons so that high velocity electrons goes and bombard the screen. And second thing is they produce focusing. Focusing means, see, the electrons which are moving are a bunch of beam of electrons which are moving out of the control grid. Of course, they are going to diverge when they interact, when they enter into the pre-accelerating anode. And what you want on the screen is a small dot, a sharp dot. So you need to focus this entire beam of electrons to a sharp dot, and that is what is the second use of these three anodes. Okay, in the block diagram of CRT, I just said that focusing anode, the center one, focusing anode is connected to less positive potential as compared to pre-accelerating and accelerating. Here I will show that the focusing anode is connected to a variable positive potential. It is connected to a variable positive potential. So what will happen is when you change this the position of the arrow mark, of course the voltage or the potential which you are going to give to the focusing anode will change, right? And what will happen because of that? Let us try to understand. Let us first label all these things: pin, base, you know already, filament, then cathode element, this is control grid. Basically it is a nickel cylinder with a tiny hole at the center. So see, I am repeating this several times because whenever you write the explanation part, these terms has to be clearly specified in the explanation, right? So that is why I am repeating these things again and again. Okay, this is the first one is pre-accelerating anode. The center one is called as focusing anode, and the last one is called as accelerating anode. Of course, these three anodes are used to accelerate the electrons, velocity accelerate the electrons, but at the same time they are used to focus. Now let us try to understand how it will be used to focus the electrons into a sharp dot. As I said, focusing anode is connected to variable positive potential. When we understand the working, we say focusing anode is connected to less positive potential as compared to pre-accelerating and accelerating. That means there will be a potential difference between pre-accelerating and focusing, and there will be a potential difference between focusing and accelerating anode, and wherever there is a potential difference, there will be a field which will exist. Okay, so there will be a field which will be existing between pre-accelerating and focusing anode, and focusing anode and accelerating anode. And now what happens when you change the positive potential or you change this arrow mark? Of course the potential to the focusing anode will change, and if the potential to the focusing anode will change, the potential difference between pre-accelerating and focusing and accelerating will change. And if the potential difference change, the electric field change, and this electric field is nothing but used to focus the electrons. So the focusing of the image on the screen will change, right? So basically in very basic term, we say we are actually controlling the sharpness of the image on the screen by the variable positive potential given to the focusing anode. Okay, so now when the electrons move out of the control grid, they are enter into the pre-accelerating anode. At the same time, when they enter into the pre-accelerating anode, their velocity accelerated. At the same time, they tends to diverge. When they interact with the first field, all the electrons moving away from the normal is converted into normal, that is beam shape, which is parallel to the axis of CRT. And then when they interact with the second field, all the electrons will converge to form a sharp dot of electron beam. And when no force is applied, this dot will travel a straight path and it will go and hit the screen exactly at the center. The internal surface of the screen is coated with phosphor. So when high velocity electrons are bombarded on phosphor, a green color illumination will be produced. This we have already discussed in the block diagram of CRT. Okay, so by changing the positive potential of focusing anode, what exactly we are doing is we are controlling the sharpness of the image on the screen, and in terms of CRT we call it as focus, right? So this knob, external knob, which will change the positive potential of the focusing anode, is called as focus. We are controlling the focus of the image on the screen. So this is what is electrostatic focusing mechanism. the explanation part of this will be exactly similar to the electron gun assembly explanation which we have discussed for block diagram of CRT. And if you remember, block diagram of CRT is divided into three parts: electron gun assembly, deflection plate, and screen. So the explanation which we will write for electron gun assembly for block diagram of CRT, the same has to be written for electrostatic focusing mechanism. This diagram has to be drawn. If you remember again, there in case of block diagram of CRT, I connected the control grid to the external variable negative potential, right? But here I am not showing it because we have already done the block diagram of CRO, so you no need to draw that particular thing. But here we are focusing or we are concentrating on focusing mechanism. Therefore it is very important that you draw the variable positive potential which is given to focusing anode, which will control the focus of the image on the screen. So this is what has to be written for electrostatic focusing mechanism. This question can be asked for 3 marks. Next, continuing with cathode ray tube, we will try to understand electrostatic deflection system. Of course, for forming an image on the screen, basically what the CRT is doing is it is forming a dot on the screen, right? But to form an image on the screen, the dot has to be moved on y-axis as well as x-axis. For that we have the second part of the block diagram of cathode ray tube: deflection plates. The plates which are kept horizontally moves the electrons vertically. They are called as vertical deflection plate, and the plate which are kept vertically moves the electrons horizontally. They are called as horizontal deflection plate. So before going to the electrostatic deflection system, I'll just tell you that whenever an input signal is given to cathode ray tube, of course either it will be given to the vertical deflection plate or it will be given to horizontal deflection plate. Let us try to get it clear that to which plate this input signal is given always. Okay, so I'll give you 2 examples. Suppose this is the screen of CRT. This is the y-axis, this is the x-axis. There are 2 screen, y-axis, x-axis. On the first one you have an image like this. Okay, on the second one you have an image like this. Okay, so now see, what we are doing is when this image is formed, it has to move on y-axis as well as x-axis, right? So it has to move from A to B, as well as it has to move from say C to D or C to D. Similarly here A to B, C to D. Okay, so y-axis is C to D, x-axis is A to B. Now in this 2 image, what you can see is the dot has been moved, right? See, this is how the like number of dots closely spaced will form an image on the screen, right? So these are nothing but dots. So the dot has moved, right? The dot has moved from right side of the screen to the left of the screen, right? Here only one cycle is there. It doesn't matter, right? Only one cycle is there, but the dot has moved from right to left. Okay, here also the dot, there are a number of cycles over here, but at the same time what you can see is the dot has moved from right to left. So what you can see is the x-axis movement of the dot is fixed irrespective of the number of cycle. Even if it is 1 cycle or 2 cycle or say 3 cycle as per this example, the dot will of course move from right of the screen to the left of the screen always. That means the movement on the x-axis is fixed if it is one cycle or 3 cycle or 2 cycle. So the movement of the x-axis is fixed. Now see the image. Now the dot has moved, right? These dots have moved on y-axis here, right? So they have this in the first example, say figure 1, it has covered the entire screen. In the second figure, it has covered only a small area because it depends upon the strength of the input signal. जो signal का आप analysis कर रहे हैं, राइट, वो सिग्नल का जो स्ट्रेंथ रहेगा उसके ऊपर डिपेंड करेगा, राइट। तो अगर स्ट्रेंथ ज्यादा है तो ऑफ कोर्स इट विल कवर द एंटायर y एक्सिस, इट हैज टू मूव अकॉर्डिंगली। बट अगर स्ट्रेंथ कम है तो इट हैज नॉट मूव्ड, पूरा y एक्सिस में मूव किया क्या, वो नहीं, थोड़ा सा ही पोर्शन लिया y एक्सिस का। इसका मतलब है कि जो y एक्सिस मूवमेंट है डॉट का, राइट, वो फिक्स नहीं रहेगा। वो किसके ऊपर डिपेंड करेगा, वो डिपेंड करेगा जो इनपुट सिग्नल का आप एनालिसिस करने वाले हो उसके स्ट्रेंथ के ऊपर डिपेंड करेगा। ज्यादा है तो इट विल टेक मोर ऑफ द y एक्सिस, और अगर कम है तो इट विल टेक लेस ऑफ द y एक्सिस। बट जो x एक्सिस मूवमेंट है वो एक साइकिल हो, 2 साइकिल हो या 3 साइकिल हो, x एक्सिस मूवमेंट फिक्स्ड है, वो जाएगा राइट से लेफ्ट पे फिर वापस आएगा राइट से लेफ्ट में। ओके, सी बेसिकली जब वो CRO इमेज बनाता है, हाउ इट डज इज, जो इमेज बनेगा, फॉर एग्जांपल सपोज एक व्हाट यू कैन से एक राउंड शेप है, ठीक है, दिस हैज टू बी प्रिंटेड ऑन अ पेज, ठीक है। आई विल टेक एन एग्जांपल ऑफ प्रिंटर। तो प्रिंटर में भी कैसा होगा, जब आप पेज इंसर्ट करोगे प्रिंट का, है ना, वो स्टार्ट, जब वो प्रिंट करना चालू करेगा, ऑफ कोर्स इट विल स्टार्ट फ्रॉम दिस पॉइंट, यहां से यहां वापस आएगा, फिर वापस आएगा, फिर जाएगा, लाइक दिस, द प्रिंटिंग विल बी लाइक दिस, ठीक है। ये स्कैनिंग मैकेनिज्म भी होता है और ये प्रिंटिंग मैकेनिज्म भी होता है, ठीक है। तो यहां से जाते समय, लेकिन इमेज कहां बना है, ये पोर्शन पे बना है, तो इतने पोर्शन पे वो कुछ इमेज ड्रॉ करेगा क्या, नहीं, लेकिन जब इस पोर्शन पे आएगा तो तब से वो इमेज ड्रॉ करना चालू करेगा। एम आई राइट? ऑन द सेम लाइंस, राइट, कि ये भी जब इसका स्कैनिंग मैकेनिज्म होगा वो ऐसे ही रहेगा, राइट ऑफ द स्क्रीन टू द लेफ्ट ऑफ स्क्रीन, वापस आएगा, फिर से स्कैन करेगा। बट वो डॉट बनाना कब से चालू करेगा, जहां पर आपका इमेज प्रोड्यूस, जिसका जितना भी आपका सिग्नल का स्ट्रेंथ है उसके हिसाब से यहां पर वो डॉट बनाना चालू करेगा। लेकिन देखो, ध्यान से देखना, द मूवमेंट फ्रॉम राइट टू लेफ्ट इज फिक्स्ड, राइट। डॉट बनाना कहां चालू करेगा, जहां पर आपका इमेज प्रोड्यूस होता है, राइट। सो मेकिंग यू अंडरस्टैंड ऑल दिस थिंग इज कि आपके पास में 2 डिफ्लेक्टिंग प्लेट्स है, वर्टिकल डिफ्लेक्टिंग प्लेट और हॉरिजॉन्टल डिफ्लेक्टिंग प्लेट। तो इनपुट सिग्नल हमेशा आप किसको अप्लाई करोगे, द इनपुट सिग्नल विल बी ऑलवेज अप्लाइड टू वर्टिकल डिफ्लेक्शन प्लेट, राइट, VDF, वर्टिकल डिफ्लेक्शन प्लेट। हॉरिजॉन्टल डिफ्लेक्शन प्लेट जो रहेगा, हॉरिजॉन्टल डिफ्लेक्शन प्लेट क्या करता है, एक्स एक्सिस मूवमेंट, वो तो फिक्स्ड है, वेरिएबल कौन सा है, वाई एक्सिस मूवमेंट। सो इनपुट सिग्नल, जो भी इनपुट सिग्नल जिसका भी अपने को एनालिसिस करना है, वो सिग्नल हम वर्टिकल डिफ्लेक्शन प्लेट को लगाएंगे। बट देयर आर सम एप्लीकेशंस वेयर यू नीड टू गिव 2 सिग्नल्स, एक वर्टिकल को, एक हॉरिजॉन्टल को। ऑफ कोर्स उस टाइम पे हम लोग दोनों 2 सिग्नल एक प्लेट्स को देंगे। लेकिन अगर एक ही सिग्नल का एनालिसिस करना है और उसको हम लोग को उसका कुछ एम्पलीट्यूड या उसका कुछ पैरामीटर पढ़ना है, तो वो हमेशा जाएगा किसको, vertical deflection plate. Okay, let us now try to understand what is electrostatic deflection system. So from the explanation which I gave you now, what we have understood is that input signal will be always given to vertical deflection plate. Input signal will be always given to vertical deflection plate. So I will explain you electrostatic deflection system on the basis of, actually what we are trying to understand is on what parameter the deflection of the electron depends on the screen. So that is what we are trying to understand. I will explain this thing with 3 diagrams. Okay, so in the first diagram, let's say this is the vertical deflection plate. The plate which are kept horizontally moves the electrons vertically. They are called as vertical deflection plate. Okay, and so this is the screen. So D is the distance between the plates and the screen, A is the area of cross section of the plate, and say potential which we are going to apply, the input signal which has to be analyzed, उसका जो सिग्नल है वो अपन यहाँ पर अप्लाई करेंगे। सपोज कोई पोलैरिटी अप्लाई नहीं किया, कोई पोटेंशियल अप्लाई नहीं किया, दिस इलेक्ट्रॉन इज गोइंग टू ट्रेवल अ स्ट्रेट पाथ एंड it is going to hit the screen at say P. But as soon as potential is applied, out of the 2 plates which is more positive will because of that, what will happen is the electrons will be diverted towards the plate, and when they move out, they will go and hit the screen, say at P dash. So deflection on the screen depends upon the potential difference. That is what we have understood by the first diagram. Okay, now what I'll do is, in the second diagram, I'll keep the area of cross section of the plate same. Okay, potential same, but what I'll do is I will decrease the distance between the plate and the screen. Okay, so let's say this is the screen. So now when no potential is applied, it will go and hit the screen at say P, but when potential is applied, it will go and hit say at P double dash. So now what happens to the deflection as compared to the first diagram? In the second diagram, what happened to the deflection on the screen? It has decreased. So the deflection on the screen depends upon, of course, in the first diagram we understood that it is because of the potential difference. In the second diagram, we have understood that when D changes, the deflection on the screen changes. Next, third. In the third case, what I'm going to do is I will shorten the area of cross section of the plate. Okay, but I'll keep D constant. Of course, when no polar potential is applied, it is going to hit the screen at P, but when same potential is applied to an area of cross section which is decreased, right? So the electric field exists between the two plates will be increased. So more will be the reaction on the electrons which are deflected. So the electrons say it will go and hit the screen say at P triple dash. Now, so when you change the area of cross section of the plate, what happened is the deflection increased. That means what in this case we have kept the ED and D constant, but area has changed, area of cross section of the plate has changed. That has changed the deflection on the screen. So deflection, electrostatic deflection on the screen depends upon the potential of the input signal, area of cross section of the plate, and D, which is the distance between the plate and the screen. Now go back to the block diagram of CRT. If you remember at the last point, what I said is this entire setup is enclosed in a glass envelope, right? The entire setup, whenever it comes to user from the manufacturer, it is enclosed in a glass envelope. Of course, when it is enclosed in a glass envelope, can you change the distance between the plates and the screen? Of course, it will be fixed. You cannot change. Can you change the area of cross section of the plate? No, you cannot change. So what is the only thing which is variable? The only thing which is variable is the potential of the input signal. So that means the deflection on the screen will be always proportional to the strength of the input signal which has to be analyzed. So that is what is the objective of understanding electrostatic deflection system. I hope you have understood.